Okay, so let me see the problem. The problem is, so we have so we have a bicycle racer. Bicycle racer sprints. Interesting. Okay. Initial. Okay, so we have a bicycle racer. I'm gonna draw a bicycle racer. I like to draw what I'm working with, so I can imagine what's going on a lot better. So we have a bicycle racer. At some point, the initial velocity is, at this point, is equal to 12 meters per second. And the acceleration is 0.55 meters per second squared for 7 seconds. What is the final velocity in meters per second? Okay, so before I start any of these, what I do is I write down all of my kinematic formulas, kinematic equations, so I know what I'm working with. Okay, so we have the final velocity is equal to the initial velocity plus acceleration times time. Final velocity squared is equal to the initial velocity squared plus 2 acceleration times distance or x or whatever. I'm just do distance. X is equal to 1/2 of initial velocity plus final velocity times time, and then x is also equal to the initial position plus initial velocity times time plus 1/2 acceleration times time squared. Okay, so what are we looking for here? For the first one, you already got the first one right, but let me just work through it. The final velocity is unknown, so we're going to have the initial velocity. We have the initial velocity, we have the acceleration, we have the time in which the acceleration is being run for, but we don't have the final velocity. So let's see. Initial velocity, acceleration, we have time, x position, but we're looking for final velocity, which this does not give us. We have initial velocity, acceleration not here, we have time, and too many unknown variables here. For this one, we have initial velocity, we have acceleration, we don't have the distance, which is covered, so we don't have enough. We have initial velocity, acceleration, and we have time. Okay, so this will give us final velocity. Yes, I knew it was going to be this first one. I just wanted to waste your time. Okay, so we use this formula, 12 meters per second plus acceleration 0.55 times 7 seconds, meters per second squared, is equal to some velocity, which, as you've calculated, is indeed 5.85. And it seems they don't care so much for sig figs, at least looking at it, because your answer has 4 significant figures. This will only yield 1, which is a terrible thing. Okay, let's wait. 1, 2, 3, 4, 5, 6, 7. Yeah, this should only yield 3. This should only yield 3 significant figures. Okay, so part B. So the racer continues its velocity to the finish line. So we had the initial velocity, final velocity. Well, I'm gonna go right down here. 15.85 meters per second. This final velocity goes all the way down. Okay, so initial velocity, then final velocity. I'm gonna move over here because it took them time to get there. Okay, so final velocity, person's at this point, they're still going, and they are at this point the entire distance. They said initially when they started accelerating, they were 300 meters away from the finish line. How much time did they save? Okay, so this is 300 meters. This distance is 300 meters. How much time did they save compared to what? I'm going to make the assumption that they're talking about time that they saved compared to if the person did not accelerate. So let's calculate how much time this would have taken if the person did not accelerate first. You can go any order you want to, but I will choose to do this. The initial velocity here is 12 meters per second. And I wrote that wrong. 12 meters per second. 300 divided by 12 is equal to your mom's house. Let's see. No, 300 divided by 12. That's equal to 25 seconds. If they did not accelerate, they would have taken 25 seconds. So let's see how to calculate how much time. Okay, let's see how much time from here to here. It took 7 seconds, and from here to here, they took how much time? The issue is we don't know how far this is. We don't know how far this distance is. I'm gonna call this DF or something. I don't know. I'm gonna call this D2 or something. It's unknown. So in order to know D2, we need to know D1. And I believe it is possible because we can find how much. We have a kinematic formula to figure out how much distance was covered over given that some body is accelerating. So let's see. So initial velocity we have here. We have the initial position, which was 0. This is final position. We have the time which they were accelerating for. So this formula will work. This formula down here will work. So the distance that was covered in D1 is going to be equal to the initial position, which is 0 meters, plus the initial velocity, which is 12 meters, times the time, which is 7 seconds, plus 1/2 0.55 meters per second squared times the time squared. And the answer we're going to get here is going to be equal to 97.475 meters. Okay, so now we have D1, which we can define here. I'll move D1 over here, come here, D1, put you here. D1 is equal to 97.475 meters. D2 is then equal to 300 minus this, which is going to be equal to, I'm not doing that math in my head, it's going to be equal to 202.525. D2 is going to be equal to 202.525. 202.525 meters. Now we can determine how long it took them to travel here. This from here to here, 7 seconds. From here to here is going to be we have the distance, we have the velocity, we're just looking for the time now. Distance, and we have velocity. Let's see what we can do. Looking for distance, we have velocity, and we're looking for time. We can use the initial velocity here and the final velocity are going to be the same because they're not accelerating. We don't know the time, but we have the distance in which they cover, so we can use this one. So x in this case is going to be equal to 202.525 meters, which is equal to 1/2 the initial velocity, which is this one, not this one. Don't get them confused. It's the initial velocity at this point. 15.85 meters per second times the time, plus the final velocity, which is the same, 15.85 meters per second, times the time in which it took them to do this. If you look at this formula right here, you get x, 1/2 initial velocity and final velocity, but if they're both the same, which is v plus v times t, it's going to be 1/2 2v t is equal to x, and you get your velocity times time equals distance formula, because these cancel out. X equals velocity times time. That's what this formula is. Okay, so we have that. Now we're looking for the time. Well, all we would need to do is manipulate this algebraically, multiply both sides by 2 to get rid of this half. And then, or actually, no, I don't even need to do that. What I would do is 1/2 of this plus this is just going to be 15.85, which is equal to 202.525 meters time, and then divide both sides by 15.85, and t is going to then be equal to 12.77 repeating, or actually not repeating, seconds. That's the time it took. So we have the time it took from here to here, which is 7 seconds. The time it took from here to here, which is 12 point, that number. Add them together, you get 19.7776 as the time that it took when they accelerated. And the time that they took normally, if they didn't accelerate, is going to be equal to time regular, 25 seconds. So the difference between that and that is going to be, the difference in these times is going to be equal to 5.222 seconds. So yeah, I did not obey significant figure laws very well. You may have to if this answer is incorrect, but I promise you the way I've gone about answering this question is the way you want to go about answering this kind of question. So yeah, that's that question. It had just occurred to me that I didn't do the second part, so I'm doing that now. Okay, so we have some times here that I'm going to carry over down here, but I need this space down here to work on this part. Okay, so now we have a bit more complex an issue. We have two bikers, the original biker, which is this one, and then a new biker, which is 5 meters ahead. At the very beginning. And this person is traveling at an initial velocity of 12.2 meters per second. And this person we know is traveling at an initial velocity of 12 meters per second, plus their acceleration and whatnot. So we'll take on some data that we acquired here in order to find out the difference in the distances between them. We need to calculate where they are at the point that this person finishes. So this person finishes in how much time? This person finishes in 19.7776 seconds. If they complete this 300 meters in 19.776 seconds. So at t equals 19.7776 seconds, the biker has passed this one, perhaps by based off of the question, I'm assuming that they passed them. So let's see where this person is at this time. So 19.7776 seconds later, they covered this distance, and let's use a kinematic formula. We have the speed at which they're traveling, the time that they're traveling. This sounds like the simple velocity. I mean, x is equal to velocity times time. So, not x, d, well, x, d, whatever you want to use, this distance. Okay, so 12 meters per second, 12.2 meters per second, my apologies. 12.2 meters per second times 19.7776 seconds is equal to the distance that they covered. Let's find out what distance they covered. .241.286 241.287 meters. Well, I rounded, but there's yeah, that's about it. So the difference between this person and this person at this point in time is going to be 300 minus the distance that the person is at this point in time, which is 58.71328 meters. This answers the first problem, the first question, which is the distance between them. Now we need to figure out how long, how many seconds this person was ahead of this person. So in other words, after this guy finished, how long did it take this guy to finish, or girl? I don't know who we're talking about. After this guy finished, how long did this guy take to finish? And that is just, at this point in time, this person is still traveling at the constant velocity of 12.2 meters per second and is covering this distance. So we have the distance that they covered, the velocity in which they're covering, and we're looking for the amount of time. So we're looking for time. We have final velocity and initial velocity, and we have the distance that they're covering. Yeah, we're going to use that formula, which I've reduced earlier, but 58.71328 is equal to 1/2 the initial velocity, which is 12.2, and the final velocity, which is 12.2, times the time that it took them to get there. We algebraically manipulate this. This one becomes 12.2, and what we get is 58.71328 divided by 12.2. The time that it took this person to finish was 4.8125639348972. Okay, I made up a lot of these last numbers, but the time that it took this person to finish after this person finished is this time. And now we have solved this question.